So we'll start. Am I audible? I think I've shared my PPT. Hello.
Yes,
Yes, sir.
Yes, sir. Yes, sir.
yes,
Yes.
So last class we talked about the hash table as an index structure. That means we want to store something so that we can search. Not only it stores a particular key value, it also stores the address of a particular file in a secondary storage. That's why we talk about different type of files, and the index is supposed to be designed using hash table. Maybe during the compilation, if you have defined some variables, it starts with, let us say, alphabet A, and let us the variable is ABC, and then you try to define a variable called ABCD. So if you want to search at the first to conclude that ABCD is a new variable, so previous value ABC is posted in the hash table so that you can search it very fast. So one of the application is in a compiler design. So here first we'll come to a typical structure of a hash table. Again, I say it's a logical structure where what we try to say, the address or the table is indexed by the value from 0 to n minus 1, or where the table size minus 1. That means if I am looking into a logical structure of the table, so this is with address 0, address 1, or address b minus 1, or I call it as a bucket 0, bucket 1, bucket b minus 1. But actually this is created in the main memory. So it suppose this is a 16-bit word, I address starts with address 0, my next address will be 16, next is 32, then is 48, then is 64, it's like that. Okay, so if I am looking to store 8-bit number, and this single slot is of 8-bit, and if I need, there will be 8 such things are there, and I have a 64-bit word, so this length will be 64-bit. So the individual locations are known as the bucket, and the numbering of bucket starts from 0 to b minus 1. And suppose there are single slot, then we can say call it as slot 1, or we can have with multiple slots. Okay, so the hash table is collection of the item. This happens, you say it's a collection of item. This happens after storing. Otherwise, it's a structure which has certain fixed number of buckets and fixed number of slots. So hash table is partitioned into many buckets, and each bucket has got many slots. Otherwise, it will have only single slot. Each slot is capable of holding one record. Here, one record means what? So suppose you try to store the detailed information about a student. Maybe that will require 128 bit, maybe more than that to 56 bit. And as I said, the hash table is used to design an index. You can do it for small information. When the information or the record size which stores the detailed information of a student is large enough, so what we try to do, we store those things in secondary memory, and address of that location is only stored in the hash table. That means if you look into for a roll number 7409, then its corresponding address is stored some, I mean the detail about the student with roll number 7409 is stored at a particular location. Then it stores two information, that is 7409 and the corresponding address where the detailed records will be found. That address corresponds to your disk address. Okay. Logically, we can define each slot holds a one record. Then we have a hash function. If somebody tried to search where I can find that record, he refer to the index with the roll number of the student, got the address or the location where the detailed information is stored. With that, what happened? Your read-write head will be positioned into that area. The whole information will be loaded to the main memory so that you can visualize. So we need a function that transforms the identifier key into the address in the hash table. Okay, so starting from the roll number, I can jump into that location where the information is available. What is the difficulties if hash table is not there? It is there is just linear array or a sequential structure. Then to find out the roll number details of a 7409, I have to start searching from the beginning of the file. I'll read past one by one record, and every time I am comparing the key value is equal to 7409, then only I can examine the other fields or retrieve the other fields. So that is the advantage in the hashing. Directly you are landing into that location where the informations are stored. So a hash function is transforms an identifier or a key value, or you can say example it's a roll number of a student, which will be stored into the address of the hash table. See, there are two things. Hash table as a index. Repeat it again and again because you don't get confused. Here, that means, let us say in a single slot, I am storing all the information about the entity, or let us say student, or here I am storing another address which will be pointing to the disk, the secondary memory, where the detail about the student, the student or the candidate is stored. So I told you about the four different file organization. So the file organization, direct or random file, they stores the information like this in the disk. Sometimes what happen, for those cases, we are not creating actually a hash table rather than simply using a hash function. But when a table is required, suppose you are finding a situation like collision, I'll explain you, then a table is required. So treat the table as an index where either you can find the detailed information related to a key, or you'll find a partial information related to the key, and then you find a direction or an address where the rest of the records are stored. So then we'll come to some mathematical terms that is related to the particular hash table. So now if we are looking into a typical data structure, first we are concerned with the operations, then mostly we concerned with the operation like insertion and deletion. So those operations has to be discussed. Then in addition to that, there are some peculiar functions. So suppose somebody asks you to create a hash table, so you say by default function is your insertion, deletion, or searching, but I want like this. Suppose data structure, I want like the operation like this, find minimum and find maximum. Then this type of data structure is highly inefficient, because unless and until you examine all the locations, otherwise you can say all locations in a single bucket, you cannot conclude a particular item or a particular information is maximum among the available information or minimum available the information. This is one of the disadvantages. This data structure should not be preferred where ordering of the elements are concerned. It is only used as an index structure whenever we want to store something into an index, or we try to retrieve something to the index. So that because those logic can be implemented in a constant time, that is the order of 1. So the mapping between the item and the slot where that the item belongs to the hash table is called the hash function. So hash function is responsible for transforming a key space to the address space. You start with the key value. It is told that all the roll number will be 4 digit. So actually you don't have any, that many number of students, 999 number of students, but any student comes whose roll number fits into that logic or format. So the hash function will take any item, it is collected, then return an integer in the range of the slot, that is between 0 to b minus 1. That means you are accepting a roll number 7409 and translating that into any number in between 0 to b1, where the detailed information about the 7409 will be stored or it will be recorded. Now, we discussed these classifications in the last class. Now we'll come to the static hashing. What we discussed in a general hash table structure that is suitable for the static hashing. So identifiers are stored in the first characteristic, which is the fixed size of table. You have to, prior to the operation or prior to the application, you need to decide what will be the size of the hash table. It is capable of storing 20 element, 30 element, or 40 element, or at a single location, how many slots are there. Okay. So the address of the location of an identifier X can be obtained directly through the transformation of the identifier to a locations in the hash table. So that's why I say it can be obtained by computing X. That means hash function, hash function will compute over the X and returns a value. The memory available to maintain the symbol table. Here we just use the term instead of hash table because you are acquainted with a compiler and other type of paper. So this is an example of a compiler, the memory available to maintain a symbol table. You know why symbol table is needed and which page of the compiler separates out the symbol and store it into a table. Suppose, as I said from the beginning, a variable is there ABC and another variable is that ABCD. Then to search, to make a faster search, we are using a hash table. So this is in the context of compiler that we can design a symbol table and it is assumed to be sequential but facilitate the implementation of the hashing. Organized in sequential, but if you tell me a alphabet, I can tell you the location where it is stored. The hash table consists of B buckets and each bucket contains a record, that is also an assumption. So it checks the hashing function match. It's a match, a set of identifier into the integer through 0 to B minus 1. Because any individual or person is coming, he has to accommodate it into that many locations. That is from 0 to B minus 1. Okay. So once this mechanism is decided, what are the things to be debatable? The most debatable part is the retrieval. How you are going to retrieve. So number of times we have discussed the way you try to sort. So that directly proportional to the way you retrieve. So storing mechanism is through hashing. So retrieval mechanism is also through the hashing. Now the first classification is comes as the static hashing. So here the identifier density we have not defined, now we are defining. Identifier density of the hash table is defined to be n by t. Okay, n is the number of identifiers in the table that are stored. T is the total number of possible identifiers. What is T exactly? Exactly how many slots are available. So this way, suppose there are 10 slots. This way you have got 10 buckets. Then you have 100 dedicated slots. So this has to be taken care of by the particular table structure or how you are going to designate with simply multiplying into S into B, number of buckets into number of slots. So depending on the memory available, this size vary. So loading density or the load factor is calculated as a alpha n by SB. Very simple. N is the total number of identifier. The total number of identifier to be mapped. SB is the total number of locations available to accommodate the n. So next, the two identifier I1 and I2 is said to be synonymous. Okay, with respect to the hash function, if HI1 is equal to HI2. This sometimes vary because when you try with a different hash function, they might be equal. So two identifier I1 and I2 said to be synonymous with respect to the hash function H. So remember it, when you define what is a synonymous, always the synonymous is defined with respect to a particular fixed things. So the things, the two identifiers is said to be synonymous. That means you start with I1, then I double one and triple one. So whatever it may be. So these two hash function will be mapping to the same location. So two identifier I1 and I2, that let us say two roll numbers said to be synonymous if the hash function H, any means you have selected a hash function H, so that the location to which they points, that is H of I1 equal to H of I2. So that is the one of the definition. You remember, sometimes it asks you to find out who are the identifiers are synonymous in a given set of the items which is to be stored using hash table. So an overflow occurs when a new identifier I is mapped or hashed by H to a full bucket. Let us say you have a single bucket. Whenever, and that means there is only, and as a you are calculating A, it goes to first location. It found that that location is occupied by double A. Okay, if that situation occurs, an overflow occurs when the identifier is mapped or hashed into a full bucket. So let us say we have a single slots. So with a single item, that location is occupied. When second element try to goes there, so that situation is known as the overflow. Okay, so overflow, sorry, that is situation is known as a collision. Sorry. An overflow occurs when identity are mapped to a full bucket. That means if my bucket contains only one element, then you collide with that, it is already occupied, so it is a collision. And if a collision occurs, but you have multiple slots, like this. Let us say we start with a simple hash function that is mod 10. So I am starting with 11. So 11 will remainder will be 1. So 11 I will insist on storing here. After that, the key comes 31. So 31 again I am applying mode 10. It goes to this address, but I found that this location is occupied. So I try to check into the next location if it is free. Okay, these are the different protocols in nature. That means if after finding the collision that one element is there, I am not able to store that item in the second location, then that condition is called overflow. That condition is called overflow. That means let us say there are 3 slots available with the address, but all are occupied. But when it says it tried to generate the address value and it mapped to the same location which is previously occupied, we call it as a collision. Okay, so this is also defines the overflow. Then that is the definition of a collision. Collision occurs when two non-identical identifiers, let us say I1 and I2. So H of I1 will be equal to H of I2. But H of I1 will be equal to H of I2. Then we can say the collision occurs. If the bucket size is 1, this is what I tried to explain. If bucket size is 1, the collision and overflow occurs the same time. Okay, this part is clear. If a single location is there that is already occupied, where you will store. Now this is a very simple example. We start with a hash table which has got 25 buckets and 2 slots. So loading density is your total element we can store here is 25 into 2. So here we have an assumption that A and A2 or slot 1 and slot 2 has got the equal capacity. Now how we try to insert? We'll go by alphabet serial number. So if you look into the G is a which number alphabet? G is which number alphabet? Is the 6th alphabet. So we developed a hash function. It will look into a key value that is the alphabet and it will map to its the corresponding integer value. That means that is based on the position of that alphabet. So that means if I am reading GA and I apply a hash function, I have returned with 6. Okay, so GA I have stored in the 6th location. Second is D. D is the third element, so it goes to third location. A is the first element, so it goes to the 0th location. Okay, D is the 4th element, goes to the 3rd location. A is the first element, so goes to 0th location. Similarly, the G then mapped to which location? Where we have stored the 64. So it tried to go there. If he finds the slot is there, it's fine. If it is not finding a slot is there, it tried to store it on the top of the GA. The location is occupied by GA, which is not permitted. So that's why we have different techniques. When the collision and overflow occurs, then we have to, if more number of collision overflow occurs, then we have to take a decision that appropriate design of the hash table is not proper. Sometimes we'll be finding the hash table structure which we have designed or proposed we are going to simply double it so that we can accommodate more number of identity. So if no overflow occurs, the time required for the hashing depends only on the time required to compute the hash function. Otherwise, why the insertion and other activities is order of 1, so we are not going to consider that. Okay. Now, to the hash function advantages, simple to compute, minimize the number of collisions. It depends upon all character in the identifier if we use a uniform hash function. So if there are B buckets, and we hope that for an arbitrary hash function H that receives any input X is equal to I, Hx equal to I, with the probability of this situation being occur is 1 by B. If there are B buckets, we are in uniform hash functions. So what we try to say? When we try to map a key value, everyone has got a equal chance, that is 1 by B. When I am trying to store to a hash table which has got B buckets, then I should comment what type of hash table it is. Okay, so whether it is uniform hash table or not. If I find this line, that probability being 1 by n, so we conclude that the particular hash table and the corresponding to a hash function, it is being examined or tested or by proof someone's that it will be mapped to a uniformly. Just like picking up a element out of a set containing n, the probability is 1 by n. So we have b number of buckets. If I take any key from the key space, or let us say roll number, it will definitely map to a location or a position in the index. Okay, so we have few definitions as you remember: uniform distribution, overflow, and collision. Now we'll come to this uniform hash function methods. Sometimes people forget to use this term, and that is the reason all the techniques, when it is explained, it mostly explained which type of hash function you are targeting. So here we are targeting uniform hash function. Okay, so we have different type of uniform hash function. Means probability of getting this number is 1 by n when we have n number of candidate subsets. Okay, so the direct method, substitution method, modulo division, digit extraction, mid square, folding, rotation, and pseudo randomness. So all these methods are very simple, and if you look into the name, we try to manipulate the key value. Suppose you say the key value is 7401, then can I map that person to the location number 7401? Or you can map the person to a 7th hostel with room number 409 or 401. So direct method, subtraction method, modulo division method, these are all possible methods I have listed. There are 8 different possible methods to design a uniform hash function. Okay, so now, so we'll discuss one by one. So the hashing method, that is a direct method. The key in the addresses without algorithmic manipulation. Directly, if you look into the key value, you have to pick up the address or the location where it is stored. So key structure contains elements of possible keys. Obviously, so example of the example is like this: to analyze the total income, sales, days in the month, you need to develop a mapping. Okay, how you will post it? Sometimes you are performing a transaction, and daily I have to note down how much credit is there. This is similar type of things. To analyze the total monthly sales by days, every day you need to record. What you need to record? Because the different informations you need to record, then you try to analyze that how the hashing takes place. So each cell we need the date and the amount. For this case, it is capturing date and the amount. To calculate the sales record every month, we need day of month as the key for the array and sales amount to the accumulate. So if you look into the transformation, so daily sales is the sales day, that means the day is the index. So that is daily sales cell step or the cell amount. This is a very simple example. Or else you can thought about a number. Suppose your roll number is 7401. You can add them, or you can after that you can subtract them or divide them. Some manipulation